Okay, hi folks. This is the second lecture of week number 8 that will be delivered in an asynchronous way. Today I'm going to be discussing two problems. One of them is from chapter 5, which is called Sliding Ladder, and the second one is a single cylinder engine, chapter 12, single cylinder engine, which is a more elaborate way of doing slider crank mechanism. Let's concentrate on chapter 5 right now. Here is the problem that we're trying to do. And we have a ladder leaning against the wall as shown. And this ladder slides down the wall at a given angular velocity or angular speed of the top, let's say, center point of the ladder at a given speed of 10 inch per second. Now, this kind of problem actually you did first time in your calculus class, which is called the related rates problem. So the thing is that you're given the length of the ladder and you're given the velocity, for example, of the top point and the initial position of the top point, and then you're asked to find the velocity of the bottom point, etc. So it was based on the fact that the length y squared plus z squared is equal to a constant, and that constant is the length of the ladder squared. And from there, you started differentiating and getting the velocities, and the acceleration is needed. So there are different ways of doing this problem, but I want to introduce you to slider joint and point curve joint in this problem, and therefore I'm going to do it in the way that may be rather awkward for you, but that's how I'm going to do that. The only thing that I need, as I said, is the length of the ladder. Of course, the initial position is important. It affects the results. In that sense, it's important. All right, so I will try to make this in 7 inches and then 0.5-inch radius on the top and the bottom, or roughly the wall being of that size. Incidentally, the formulas that you did in your calculus class or your probably dynamics class, it's going to tell you that the velocity at the bottom point is given by this expression and acceleration by that, based on the approach that I gave you. And they're plotted here. Okay, so let's go ahead and let's go to CATIA, and I started with a product file, and then immediately I'm going to save that file, save management, save as, desktop, desktop, new folder. I'll call it uh, sliding ladder, and this is June 5 lecture. Okay, let's do it in that folder, put everything in that folder. All right. Let's insert the wall first. So actually I'll do the ladder first. So insert insert a new part in there, and I'm going to call this thing the ladder. Right click properties. The name of the part is down here, or part number. Oops, right there. Ladder, and the instance is up there. Ladder. Okay, we make it. Double click on the part right there. You're in part design, so on a convenient plane, let's say on that, on that plane. Why is that plane? I will draw something that looks like my ladder, and it looks like so. We'll dimension it in just a minute. Now notice that I was going to make a circle here, and I missed the opportunity. Left click, hold down, and drag a little bit. But that's okay. You can always go to here to sketch tool and clean it up right there. See that? You come down here, and then left mouse button down, drag it a little bit, and it turns into a circle. Otherwise, you do it with what I just showed you. Okay, let's put some dimensions and dimensions. This line is 7. Wait a minute. What was it? 7. Yeah, 7 inches. 7 inches. And these radii are zero point 0.5. If I change this thing to zero point 0.5, the other one I think automatically is, well, it didn't because I don't have a parallel constraint, so that's okay. 0 0.5. There. This is the ladder. Exit. And I'm going to pad this thing by, let's say, 1 inch. Okay, so pad it by 1 inch. Point, uh, make it 0.5 inch. 0.5. All right. The other thing that I'm going to do, I'm going to create 2 points, one at this end, one at that end. So let's do in this part, in this ladder part. So click on the point, and there are different ways of making the point. So I'm going to use the circle and sphere's ellipse center. So I select that. So notice that the point is going to be created right there, and I do another one on the other side. The reason is that I want to find the velocity of this point, for example, while the point on the top is sliding down uh, the wall, kind of. So this is taking care of it. So let's go to the product immediately, product level. See that? Double gear, click on the floppy, and this part is going to be fixed, or not fixed, but saved. So insert a new part, say no, and I'm going to change this thing to wall. Right click properties, wall, and wall down here. All right. So let's double click on the wall. We're going to go into part design. I'm going to be making the wall. So on this vertical plane, I will sketch something that looks like the L that you have, making the wall. So perhaps something like that. There is the wall. There. Exit. And once again, pad it. Let's make it 0.5 inch. 0.5 inches. They don't have to be the same width. In fact, the width has nothing to do with the kinematics of the problem. Now, you might wonder why, but just be patient and you see the rationale behind what I'm going to do. Notice that this point, when the ladder is leaning against the wall, the way I've constructed it, this point is always half an inch away from the wall. And that point is always half an inch from the horizontal wall. Now, I'm not going to worry about that because I will do slide curve joint, which is that curve at the end slides along that line. But for this point, I'm going to do a point curve joint. So I'm going to draw a line, straight line here, which is half an inch from the wall. And eventually I make that point to always slide, not slide, but move along that line. So here's the reason that I'm going to make this line for you. I just explained it. So on that plane, on that vertical plane, I will sketch a line like that. Okay, something like this. I'm going to make sure that it actually goes, it touches at the bottom point. So, so this point, although it's not important, but I will do it anyway. This point, control that point, that line. We're going to make it coincident so that it lifts it down and puts on it. Okay. And let's see now, this thing, let's make it about 8 inches. Okay, 8 inches high, maybe 9 inches high. There, I'll make it 9 inches high. All right, fine, 9 inches high. Very good. That's pretty much it. Exit. And that's it. So let's put it in a good isometric view. Excellent. We go all the way on the top, all the way on the top, click on the floppy, everything. Oh yeah, I forgot to actually put this thing half an inch away from the wall. So let's go back to that sketch. I forgot. It just it looks nicer when we do it like this. So the dimension from this line to that line, half an inch, 0.5. Good. Now exit and save. This is in case the CATIA crashes, power is lost, we have stuff. Okay, let's go to product, double click on the top line and then floppy. Okay, good. So now we're going to go, assembly constraint. The first thing we're going to do, we're going to fix the ladder. So use the anchor to fix the ladder. This is assembly constraint. What I've done here is close the stuff that I don't use very often for these problems. So I've constrained, which is extremely important. And I don't even need this. I don't even need that. Okay, so we have the move toolbar and update. Okay, and a split in case I need it. I just erase. I just uh, you know close everything else that I don't need. All right, good. So we're gonna go to we anchored this. Now we're gonna put this point on that curve. So point coincidence between this point and that line and update. Okay, good. Now this, I want to bring this surface and put it on that surface. And the way to do it is by using the contact constraint that we have not used so far in the course, in this part of the course. That's not the same contact as FEA. So that face and this face, notice that there is external and internal. This means that they're externally going to be uh, contacting each other. If one doesn't look good or doesn't look right, change it to the other one. But this is, I'm sure it's going to be okay. Right. The only thing is that I don't want this guy to be at the bottom. I'm going to move this thing up. So let's use the move toolbar and manipulate icon and make sure this check box is this box is checked, because when I move this thing up, translate it up, I want these two to remain in contact with each other. So I'm going to say translate in direction Z. This is direction Z. I'm going to drag this and notice that when I move it up, because this box is checked, these two stay in uh, contact with each other. Otherwise, if I did not do that, this ladder would horizontally move up in a horizontal position. Okay, good, good. Let's make sure one more thing. I noticed that it is possible that for some reason, because of what I did, these two are not flush. Okay, you can see that. I want them to be flush, or these two are not flush. So to do that, I can say coincidence between this face and that face and update. It will push this thing in. Let me show you here. Right now it's off that plane. But when I made coincidence between this plane and this plane and I update, it just pushes it and everything is going to be the way they are. And this last one, I really don't need it. Okay, I can delete it because you'll see if I left it there, it will lead to what is called a planar join. I'm gonna delete this last one. Okay, good, and that's pretty much it. So let's save everything. So now we're gonna go to uh, digital mockup, DMU kinematics. We're going to go into the new workbench, which deals with kinematics and stuff like that. So let me move these things out of the way. And I don't need this. I'm going to close the stuff that I don't need it. The important things that I need are these toolbars that are left kept here on the top, okay? And of course, in case I need the update is also there. And this knowledge toolbar generally in the utility position, uh, at the very bottom. Okay, good, good. Let me also move the knowledge up because if you want to put physics into the problem, you need this knowledge toolbar. All right. Now, first of all, I put some constraints in my assembly design, and I want to turn them automatically into joints. So you click on the magic one, this auto create, new mechanism number one, auto create, and you see that some kinematic or some mechanism was created. The degree of freedom is one. Let's look at our joint, and you'll be surprised. It says revolute joint. If I had not deleted incidentally that other constraint, you would also get the planar joint probably. And though this is totally nonsense, okay? It happened because of what I have here, and I don't need it, so I'm going to just delete it. Just gone. I don't want to delete the constraints in case I ever have to go back to the assembly constraint and I need it for. Oh, they say I should have said do not delete. Yeah, just a second. No, no, cancel. I want to delete this. Do not delete the children. Do not delete the children in case I ever need it. Okay, good. That joint is gone. Now, what you want to do is to create a point curve joint. So if you look in this toolbar, of all the joints, you have the point curve joint right there. In order to be able to create a point curve joint, the point must be on the curve, and it is. If not, otherwise you get a message saying that there's a gap distance between the point and the curve, and you won't be able to do it. But here it is. It is the point is on the curve. So curve is this line, and the point is that point right there. Okay, say all right. I will come back and do this thing length driven, but not now. We'll do that later. And then, although I could have drawn a line here and that this said this point stays on that line, another point curve joint, I'm going to do it a different way. I'm going to do it using slide curve joint. So this curve slides along that curve. By the way, notice that this doesn't have a command associated with it. Point curve does, but not slide curve. We say okay. So here we have a point curve and a slide curve. Degree of freedom is 1. And in order to do the rest of the problem, we have to turn this thing into 0. Now remember, slide curve does not have a command, but point curve does. So double click on it, make this length driven, okay? And then we say okay. Mechanism can be simulated, and let's see if it works. So here is the simulation with command manually. Single degree of freedom. Incidentally, notice that this did not start all the way from 0 because the 0 of this line is way on the top. Okay, so it's actually at this location that I brought it to is 4.1248. This comes into the play later on. So let me record it here. 4. Well, I have to write it down because we're going to need this number later on. 4.1248 inches. That's because when I put the point on the curve, I just happen to select that location, and that's what happened. Now, good. Okay, so let's see. You go this way, this goes down, and obviously you go this way, it goes up, further up. Okay. Now, if you want, you can put this thing in the very top, and in fact, this is what I'm gonna do. Okay, if it's bothering you, and you want this thing to be, somewhere on that wall, you have two choices. You can make this the length of this wall higher, or because this vertical portion does nothing. It's just this line is doing all the work. Okay, so if I put it at position 0, then I guess I don't need that 4.1248 anyway. So we say okay, starts there. Let's double click on it. Oh, not this. Now, so obviously it is manually it is working. Let's go and create a simulation. Mechanism number one. This is even not at the point, see, this is not at the point 0, it's 1.5. So this distance is 1.5, and I need this number, 1.5. 1 point, I may need this number, 1.53. Okay, good. So we say, okay, let me see if I drag this thing. It doesn't make a difference here. Reset. Okay, good. 1.53. So that distance is 1.53. Okay, that's fine. You just give it the way it is. Now, I take this sliding bar and drag it so that that thing moves and it goes all the way to the end. Okay, and then insert. Remember, we have done these things. Insert, rewind, and change this thing to anything but one. And if you want to move it, continuously in one direction, it goes like this. But if you wanted to loop it in two different directions, excuse me, it goes like so. There are no physics. This is just a cartoon. Okay. So we stop this thing and rewind it and say, okay. Now we're going to put some physics into the problem. All right. So if I go and click on f of x, this thing opens up. And then when I click on the mechanism, only the stuff related to the mechanism pop up. There is time and there is a length. And this length is that distance 1.53. Right now it's 1.53. However, what I want to do is I want to move this thing down. So I'm going to say this distance, that distance is equal to, not 1.53, add a formula, equal to 1.53. Don't forget inches, dimensions must add up properly, or entities must add up properly. So 1.53 inches plus the velocity was 10 inch per second, inch divided by 1s. Or if you want, you can write 10 times 1 inch over 1 second. That's entirely up to you. Look, I can write it like that, or I can write it as 10 times 1 inch divided by 1 second. You just have to make sure that whatever you do eventually adds up inch equal to inch, and there are no syntax errors. If I had left out probably probably that star, I don't know, it might have given me an error or something like that. We can try it. And then times time. Time is right here. Double click on it, it puts it right there. And if there are syntax errors, we're going to get it up right here. It says they're not homogeneous. So, oh, I forgot this. Oh, there's cancel. No, 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 no. There's, oops. Let's try it again. Let's double click on this. I had an extra I here. That's what it's saying. I don't understand what you did. So this is times 10 times, not 10 I times. So you just left it there. And no errors. Oops. Is this something? Let me see for a second. This is good. Active. It says no. Let me see for a second. This is, oh, we can, that's all right. Let's go ahead and see what's going on. I don't like that no message there, but that's okay. Oh, this is the law. Okay, let me right click activate. Something must be wrong here. Let's try to make a change here, see whether it makes a difference, because I don't like the fact that it says not active. And let me, I don't think it has anything to, I'm pretty sure it has nothing to do with what we did. 10, okay, that's what I did. 10 inch, 10 inch divided by 1 second. Okay, 1.53 inches plus 10 inch divided by 1 second times time. Yeah, the, see this thing, I thought that updating this would come on. You know what? I don't like this, so let me delete it. Let's do another one. Okay, so one more time. On the mechanism right there, this is the dimension, this is the length dimension. Add a formula equal to 1.53 times 10, 1.53 times inches by n plus 10 times 10 inches divided by 1 second times time. I'm hoping that I won't get that on the time. Double click and say okay. Yeah, look, I don't know that business of changing the units and then doing it again. It messed it up. It should have worked. It will work, but I did it again and just I don't have this deactivate sign there. Very good. Let's save it, by the way. All right, so we're going to do simulation with laws. So let's do simulation with law, and then later on we're going to put a sensor here and plot the velocity and stuff like that. So let's do simulation with laws. Now, default is 10 seconds. So 10 second times 10 inch per second, that's going to be 100. That's a lot of, so let's make it one. That's a lot of distance that's going to travel, which it won't obviously. So that's going to be maximum of 10 inches. So this is even this is too much, but we'll find out. So if we play this, actually it reaches down below before 1 second. You know that, but I'll just leave it the way it is. That's okay. That's okay. That's fine. So we say close. Now we're going to create a sensor here, uh, speed acceleration sensor right there. Speed acceleration, speed acceleration. Click on it. This is the ball rolling down the hall, and I want the father. The reference product is that wall, and the point that I want to plot something is going to be this point, and it's going to be the y component later on. Y component of the velocity. Okay, so that's good. And now we're going to go and click on the simulation with laws. Simulation with laws, activate sensor, activate sensor. Now, if you don't get the whole thing, let me cancel that for a second. We did create it here, right? Yep, it's right there. So let's try it one more time. Where is that ball rolling down a hall? Down. Oh, we already have it. I don't want to do another one. So let's see. Let's double check on this. Yeah, activate sensor. Yeah, activate sensor. So what do we want? We want the only thing we want is the y linear speed. Y linear speed. Okay, y linear speed right there. See, notice change from yes to no. I'll move this thing out of the way. Let me move the tree up there, and then we're going to play. Remember, 1 second actually it's too much too long a time, but that's okay. We're just going to go. All right, and we can make this graphics, and it's going to show you the velocity component of y of that point as a function of time. There we are. Okay. Now you might say, "Oh, why does it look like that?" Okay, so what we can do is let me close this. Okay, let me change number of steps. Rewind this thing. Make sure you clear the history, and let's change this thing to more steps, 80 steps. Okay, everything is the same. You just like clear the history and change this thing from 40 to 80. Play it. Notice that it actually looks like it did go further, but that's okay. Graphics. So you can cut down on this amount. This is actually the discontinuity. This is actually discontinuity in the the speed. Basically, it's, suddenly jumps to a certain value. So anyway, just remember on the test, if I ask you to generate such something like that on the final exam, first of all, zoom out here. I did zoom out, the usual zoom out, and then you're going to go print screen, start a, for example, a Word document, paint the stuff, paste the stuff in it, file, file, save as. We have the folder there called slider, no, not slider crank, slider crank. I don't see it here, so let me go ahead and it was called sliding ladder, right? So browse sliding ladder. That was from yesterday. Sliding ladder desktop, sliding ladder. Must be somewhere down here. Sliding ladder. Yep. My plot of y velocity versus time. Remember, on the final exam, we will ask you to generate stuff, graphs like this. I don't want any more than I asked for or any less than I asked for. If I say, show me the y component of the velocity as a function of time, this is the only graph that must be on that paper. Okay? Nothing else. Thank you. So let me close this, and I'm going to close that, and we're done here. So let me rewind, close this, save everything, because I want to do my second problem. The second problem is without doing any dimensions, I want to create this slider, a single cylinder engine. Okay, so let's go ahead and do that. This is a good practice for using some of the functionalities that you may have not used for a while. We're going to do this. So let's start with a product. I'm going to ignore all dimension. Notice that I can do everything in here, but this is not assembly design. I prefer to be in the assembly design. So I change to assembly design. Double gear shows up. And I'm going to save it immediately. File, save management, save as. Uh, One level up. I'm going to say, for example, here, new folder. And I'm going to say single cylinder engine. Single cylinder. I'll make it for July 5 lecture. Something like that. Okay, so let's start with the piston. So insert a new part in there. Let me call this thing piston. Right click properties. Piston and piston. Keep in mind that you have to be organized here. There's going to be 6 different uh, parts, and you don't want to overwrite each other. Double click on the piston, and I'm going to make it. So on a convenient plane, on that vertical plane, I will sketch something that I will shaft in just a minute to get the piston. So let's go ahead and do this. We're going to draw something like that. This is going to be the cross section of the piston. It's okay. We'll clean it up. This is the piston ring. I'm going to make just one of them, not two, not more than one. Go down. This is going to be the cross section of my piston, and like so. Very good. except that this guy I want it to be horizontal, right? Put the cursor there, right click, horizontal. Very good. And now exit and shaft it. Okay, and the only thing is that I think this is too big. So let me move this thing here. It's going to be a very fat piston if I did that drawing. Maybe this is more, yeah, this is more respectable. Exit, and then we're going to shaft it. The same place that you have a toolbar, that you have a pad, you have the shaft here. It says what is the axis? Axis is Z. Put the cursor there, right click Z axis, 360 degrees. Okay, very good. Except that my piston, I want it to be first of all hollow, and there's going to be some planes here. So let's cutouts here. So let's do the cutouts first. So on that page, on that, let me see, where is the isometric view? There. Okay, so let's make the cutouts there. So on that on that on that plane, we're gonna sketch. Actually, let me get out for a second. Sorry, on this plane, on the YZ plane, I'm gonna sketch. There are different ways of doing it, so you do whatever you want. Get the piston any way you want. So I'm gonna draw a rectangle here. You might wonder, why am I doing these things? You see, just bear with me for a second. Exit, and then make a pocket. A pocket in both directions. That's what I was doing it. Now I want to do the same thing on the other side so we can actually mirror this operation. So I think this is the mirror with respect to, okay, let's do this for a second. Let me cancel that. Select the pocket. I want to mirror it with respect to this plane right there. You see this? Now I'm going to hollow it out. And hollowing out operation is shelling operation in desktop feature. You click on it. Oh, before I do that, let me actually draw my hole there, because there's going to be a hole through this where the piston pin is going to go through it. On that face, I will sketch, and then we're going to hollow it out. So a circle, the piston, the piston pin is going to go in there. So we're going to make a pocket all the way through. Last, right there, goes all the way through, and then we're going to hollow it out. So here's the shelling operation. It says thickness is, let's leave it at 0.39, and faces to remove this face. And if I say okay, you see what happens. This is fine. It actually hollowed it out, except that it left this guy here. So I need to include that too. So if you go to shelling operation and also select that, it's going to take both of these out. And let me make this thing a little bit thicker, maybe 0.05, maybe. Not really, doesn't matter. Right there. This is my piston. Okay, let's go ahead and save. Please make sure you do this thing in its own folder, give it name, do not overwrite one with the other one. Click on the floppy. Okay, why don't I make the pin? The pin. So insert a new part, call it the pin. That's very easy, it's just a cylinder. So let's rename this thing, properties, and make it pin, and pin. Okay, let's go to the pin and make it. All it is a cylinder. So on that, for example, plane, on that vertical plane, I will sketch, project that circle, okay, project that circle, and exit, okay, and pad it, in both directions. And I'm going to use up to a plane, up to this plane. Did it work on the other side too? Oh, I guess I have to do the other one. So I thought that mirror extend would have done it, but it doesn't look like it. Let's try it. Okay, this is up to that surface. For this one, also do up to plane and select it on the other side. Okay, that's going to be fine. There we are, right there. Just because I'm making these in place doesn't mean there are any constraints. We have to come back and do assembly constraints. So we go all the way to the top, all the way to the top, click on the floppy. All right, let's do the connecting rod. So insert, a new part, say no, and make it conrod. Right click, properties, conrod, and up here, conrod. Let me say okay. Double click on the conrod. Let's go make it. So on that convenient plane, on that same vertical plane, I will sketch. Why don't I project the piston pin on it? So project the piston, not the piston pin, that circle, that's what I meant. And then look at the view from the front, right there, and make the rest of the connecting rod. So we're going to draw it and then clean it up, because I don't want to spend too much time on cleaning up operation at this point. So we go up here, turn it around. Hopefully this is symmetric. Otherwise, you come back and fix it. Down here, we can fix these, and right there. Oops, we just leave it there. Okay, so let's do a little bit of a cleanup here. So this point, control that point. We're going to make it coincident. Good. Okay, so let's do this line, this circle. I think this circle and that circle, or let me hide these things so that we can see it better. Okay, this circle and that circle, I don't know whether it's concentric. I don't think they are. So this, control that. Let's make it concentric. Okay, good. Very good. And then this line, control that line. Uh, Control the middle axis. We're going to make it symmetric. See what happened here. And okay, so let's make this center, control that line, make it coincident. If things go in the wrong direction, we go and clean it up. Okay, so one thing I don't like the fact, oh, this radius, let's see if we can make this radius bigger. Let me see. Maybe, let me make it one, see what happens. Well, the problem is that it's doing both of these, and that is happening partly because of probably that tangency. Okay, so let me do the following. I tell you what, it's up to you whether you want to go and change this thing so that it looks like that. Okay, and it can be done. It's just that how much time you're trying to put into it. So let me do the following. Uh, yeah, I'm sorry, I have to bite the bullet and do this thing the way I want it. So let's try it. Let me get rid of this. I had to do it. Okay. So let me do the following. So a line from here to here, and okay, good. And then we can mirror this thing. This, mirror it with respect to that. Okay, good. And then close this with a circle. How about doing it with this guy? This is the center, goes from here, here, there. Okay, it wasn't worth it, but I did it. So hopefully this is all nice and symmetric. Yep, and then a hole at the bottom where the crankshaft is going to go into. Yeah, okay. Exit. Pad it in both directions, but not that much. Let's put down 0.2, see how it looks like. Okay, so let's bring the other guys from the hide and show, hide and show, and we have this configuration. Go all the way to the top, all the way to the top, and save it. Okay, let's do the crank now. So on a convenient plane, on same vertical plane, I will sketch. Oh, sorry. Oh, be careful. This can happen, and it's very common. So insert new part. Don't do the other part in the thing that you were just doing. Insert a new part. Right click, properties, crank, and crank. It's very common that people don't pay attention and they make the other part in the part that's already being made, and then of course things don't move the way they want. So double click on the crank. Let's make it. On that same vertical plane, I will sketch. Why don't I project the circle? Project that circle. Good. And then let's do the rest of it. Exit and pad that circle. Let me do it by, yeah, that's good. That's good. I'm still working on the crank. So on that face, I will sketch because I want to do something that kind of looks like this. Okay, and you can see what I've done. So I'm going to draw a piece of the crank, the rest of the crank, perhaps something like that. Did I project it? Yeah. Let me hide. Let me hide this because I think I projected it. Yeah. Let me hide this. Hide that. No. Exit. I thought I projected it. So let's go ahead and find out what's happened. Hide and show. Right. So on that face. Oh yeah, that's yeah. I did project that. In fact, I padded it. That's okay. I want to do the rest of the crank. Sorry. So perhaps something like this. And you can make it nice and symmetric if you want, but I'll just leave it the way it is. Okay, good. Actually, I don't like this, so I'm going to make that this circle. Control that. Make it concentric. Yeah, that's better. Good. And if you want, you can make these tangent, but I'll just leave it the way it is. Okay, good. Let's go back here and make another circle. Let's go back to that sketch and make another circle here. So another circle right there. Exit. Okay, so actually I want to pad this thing, but this makes a hole. So I have to do a multi-pad, which I don't want to do in this problem. Let me go ahead and delete this circle. Exit. Now pad it, too much. We make it 0.4, okay? And on that face, I will sketch a circle, like so, exit, and pad it. We make it a little bit bigger. So what you see here is actually half of this. Don't worry about this ring. I will do it in just a minute, okay? I want to mirror this thing. So I want to mirror this. Where's the mirror? Mirror this entire thing, this entire crank about the plane over there. So this is going to be my crank. Let's get the other guys out. Hide and show. Good. So this is what I've got here. And finally, I want to make actually the path or the base or the thing that this thing moves on. So let's go ahead all the way on the top, all the way on the top. Save everything. Insert the path. Insert, new part, or yeah, or the cylinder if you want. Let's call it no. Let's call it. This is the piston. Let's call it cylinder. How about that? Right click, properties, cylinder, and cylinder down here. Say okay. Let's go make it. Double click. And I'll do some few steps that may not be obvious to you, but that's okay. Just be patient once again. So on that top face, I will sketch. Okay, let's fit this thing. Good. Now you might say, well, why are you doing this thing? Just be patient. So we do a projection of this, okay, circle, big circle, and then I do a little bit of a cleanup here. So I'll do how about a center? How about the rect? How about the center rectangle to make my job a little bit easier? Okay, so maybe uh, yeah. Actually, let me do the regular rectangle. Okay, yeah. Uh, yeah. Cancel, 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 cancel. Another circle. I'll do another circle. Nope. Yeah, let's do another rectangle. Just a rectangle, rectangle. Okay, yeah. You'll see right there. And I can make it clean up here. So for example, this line control that line, control this axis, make it symmetric. All right, and do a cleanup here using the multipath, not multipath, the quick trim the eraser. I want to get rid of this, and I want to get rid of that line. Okay, and exit, and uh, pad it in this direction and in the other direction. So I'll do a more, and then we go, oops, more down here. So what I'm trying to do for you is to create this, okay? So where is it? Let's do a little bit more. Good. Actually, I'll make it, yeah, something like that. And those, you see this right there? And those rings that you see here, those rings are actually where the shaft of the crankshaft is going to go into, which belong to this piece. So, for example, I do on that face, sketch, okay? Why don't I project that circle, and then exit, or actually let's go back into it. Let's go back into that same thing that I projected. And I then add another circle concentric with that because I want to make a ring actually. Something like that. I'm sure they're concentric. Exit and pad it. Not that much, maybe point, I don't know, 0.2. See how it looks like. Yep. And then mirror this pad on the other side. So mirror with respect to the right plane. Let's look at our correct plane right there on the other side. So I have completed all the pieces. Now I have to assemble it. Okay. So, wow, that took longer than what I thought. That's okay. All right. So why don't we anchor the cylinder right there and move everything apart so that we can assemble it properly. So I'm going to move this thing in the X direction. Move this thing there. Move this thing here. And move that thing there. So these are the parts that I created. Why don't we put the piston in there? Coincidence between the axis, this not axis, but this plane, this vertical plane of the piston and the vertical plane of the cylinder. Already they are, because I translated in the X direction, already they are coincident. There's nothing to update. And then axis of this piston and the axis of the piston and the cylinder. And now when I say update, this will rush and stick in there. Okay. Now let's put the piston pin in here. So we do coincidence between the vertical plane of the pin and the vertical plane of the piston. Same vertical plane of the piston. Now this was the YZ plane. We select the YZ plane. No, cancel. I selected the wrong one. Coincidence between this one, which is the exit plane, right? Exit plane of the pin and the exit plane of the piston. You can see that already they are, because I translated, they are coincident. That's why there's nothing to update. And coincidence between the axis of that and the axis of this. Okay. Now, if I update, this is going to go in there. There is no problem. It will go in there. But it has the ability to spin about this axis itself. That being the case means that there's going to be a persistent 1 degree of freedom that we cannot get rid of. So what I'm going to do is I'm going to also make a coincidence, for example, between this vertical plane of the pin and the vertical plane of the piston, make them coincident. That means it cannot spin about its own axis. And this is why you will get basically it's rigidly attached. This is going to be rigidly attached to the piston because it cannot move sideways. It cannot move this way sideways, and axes are lined up. And this basically means it's rigidly attached. So let me do that here so that we don't have to come and fix this thing. So we say coincidence between this plane and that plane is the YZ plane of the pin and YZ plane of the piston, and this will make this whole thing into a rigid joint between the pin and the piston. Okay, let's put a connecting rod in there. Coincidence between the vertical plane of the connecting rod and now this one is the XZ plane of the connecting rod and the XZ plane of the, for example, the piston. And there's nothing to update because all I did was to translate this thing. And coincidence between the axis of the connecting rod on the top and, for example, the axis of, I can use that pin. Let me turn this thing around. I can use the axis of that pin and update because the pin and the piston are rigidly attached to each other. You know that. Now, coincidence between the axis of this, well, actually, let's do it same order. It's not important. Coincidence between the vertical plane of the shaft, this vertical plane of the shaft, that is the XZ plane of the crankshaft, crank. Okay, so XZ is it XZ plane? Your XZ plane. Let's see now. Your XZ plane of this, and the XZ plane of the, for example, the pin. Not the pin. Sorry, the connecting rod. Conrod. Again, there's nothing to update because it was already there. And coincidence between this axis and the axis of the connecting rod, and update is going to go there. And now this is going to go stick into that hole. So coincidence between the axis of this ring and the axis of that shaft, and update, and there we are. Okay. Did we put everything that we needed in there? So first of all, let's go ahead and save this. All right, so if you go to move and make sure this box is checked, and we're going to rotate about this axis. Everything must move the way they are. So let's see. Right there, right? Yeah. So this is a good sign. We close it. We go and create the joints. So let's think about it before we do that. There is going to be a revolute here, a revolute there, a rigid between the pin and the piston, and a revolute between the connecting rod and the piston, and a prismatic, either a prismatic or a cylindrical joint between the piston and that piston and the cylinder. Okay, so we go to the digital markup, DMU kinematics, get the magic wand out, get the magic wand out, new mechanism, 6 joints, auto create, there we are. And I bet this is going to be a single degree of freedom consisting of several joints. Yep, you can see. Revolute between the crank and the connecting rod, cylindrical. I told you between the, well that's okay. Some of these that we may have to fix. I don't know, depending on what we have done. Yeah, so let's go ahead and find out what it is. So let's see now. Let's make this guy angle driven. So that is the between the piston and the crank, or the cylinder. Sorry, the cylinder and the crank. Let's make this thing angle driven. 0 and 360. Mechanism can be simulated. Let's create a simulation. Actually, you can do that manually, but I'm going to do a simulation. Drag this thing all the way to the end. Insert, rewind, rewind, anything but one, and play it continuously. Yeah, no physics, strictly cartoon. And please keep in mind that two people may have the same mechanism, but with different joints, depending on how they proceeded in making these constraints. As long as it does what it's supposed to, it doesn't matter. If you go back to the video segment from last year, summer of 2021, in all likelihood, you get the same mechanism, except that the joints may be a bit different. Okay, and this problem was done several times in different years. Okay, this is the current one. That's what you see. I did it last year, and over the past, I don't know, maybe 6, 7 years, every year I've done this thing, and every year there's a video of it that is, or not every year, but some years there are videos of it that are posted in my channel. Okay, no physics here. What we can do is that we can specify the speed of that crank and find, for example, the acceleration of the piston, etc. When you think about it, this is nothing but that single cylinder engine, a single not single cylinder, that is nothing, it is nothing but that slider crank mechanism, but it's got a lot more into the parts that are made. Okay, anything that I want for this problem, I could have got from this slider crank mechanism last week. Good luck. Please don't wait for things to pile up. Also, make sure you save these things the right way, at least in my assessment. For example, here, look at what I've done. I created a folder, close this, a folder here, which was called Single Cylinder July 5th Lecture. All the stuff is in here. The product, piston, pin, cylinder, crank, and conrod. It is so easy to mess these up when you have three problems to do everything. And I've seen people doing it on the midterm. They put everything in one folder, and then things got really messed up. Okay, if I ask you to generate any plots and include it, generate only those plots, nothing more, nothing else, and do a print screen, save it in a Word document, and put your Word document in this folder as a part of that problem.